Welcome to BatNav's first webinar in our Seller series. Today, we're going to talk about a circular economy meeting energy storage with green gravity. So what is a circular economy? It's about making products and systems and using them in a way that we can reuse them and recycle them. And ultimately, it reduces the intensity of using resources in our society, and that should be better for the planet. Why is it relevant for energy storage? Well, energy storage is going to grow rapidly over the next 50 years. To 2050, AEMO is projecting in its integrated system plan, we will have 50 gigawatts of storage and demand response capacity, and that there will be multiples of that number for gigawatt hours of storage. Currently, only 10% of Australians' lithium-ion waste is recycled. And over the next 15 years, we'll see a 20% year-on-year increase in the amount of lithium-ion batteries that we use. So what is gravity-based energy storage and how does it fit into the energy storage ecosystem? It's pretty simple. You lift and lower weights and capture the energy as the weights go up and down via electric motors. But does this really work and can you make money out of it? Well, Energy Vault recently listed on the New York Stock Exchange and raised $235 million from reputable investors, including SoftBank. But how does it work? So at ground level, a mass sitting on the ground doesn't store any energy. But if you lift it or lower it to a height of, say, 10 meters, you can generate 100,000 joules of energy or create a potential energy of 100,000 joules, which is about 27 watt hours. It's not huge numbers because a lithium ion battery, two of them together, creates 22 watt hours in a very small size. So can this really work and can it scale? Mark Swinnerton from Green Gravity is here to tell us how. Mark, thanks for joining us on this BatNav webinar. How are you going today?
Thanks, Dave. Fantastic. And thanks very much for having me on the show today.
Yeah, Green Gravity is a great example for me about what energy storage is. Diverse systems, different technologies, meeting that need of supplying energy storage to help accelerate the energy transition. It's very exciting.
Absolutely. Very exciting. And at a time when the world is undergoing such a transition, we have to change our entire energy system and we need so many new technologies to come to bear to make that really effective and low cost.
Yeah. And you've been experienced in global operations for BHP at the executive level. So you've made a big leap out of a totally different industry. Related, of course, so it's kind of like myself, related, but into a new role where you've seen an opportunity. And I guess you're bringing together different aspects from your previous career, your career that you have, into this new venture. It's really a really creative leap.
Look, it's quite right, Dave. And for many years, I've been involved at looking at, analysing and being part of the energy transition as it pertains to the natural resources sector. And post-Fukushima, when things really started to heat up in relation to, well, what about energy security? What about how that intersects with the climate challenge? I've been very interested in the area and have spent a lot of time thinking about the nature of the energy system and the challenges of the transition. And it came to me to arrive at a conclusion that I needed to do more. It was time to conclude my career in resources and open a career in clean energy and make a difference myself. And I feel like we've got such an opportunity at the moment, at this point in time, for so many people to contribute to this enormous challenge of converting the energy system to be low carbon. Yeah,
definitely. I definitely feel like there's a lot of people that have got to that point, and I don't know if it was COVID or other factors, but everyone seems to be pushing in the same direction at the moment, and we want to make sure that continues.
I couldn't agree more. I mean, one of the things I've noted since leaving BHP and joining Green Gravity, the number of people that reach out with great support and offer support and ask what can they do in their own way to help with the success of Green Gravity and helping us make a difference to the climate, to the energy transition. So it's really pleasing to see the overwhelming support that we receive from all quarters.
Yeah, great. It's very exciting. Well, let's tell our audience a little bit more about Green Gravity. We'll talk through a bit of the backstory, your track record so far, where your system excels, and hopefully we can help them understand, how your system fits into the energy transition.
Looking forward to it.
Great. Mark, tell us about what Green Gravity's backstory is.
Well, it started, of course, in the mining sector. and trying to understand what could be done to help mines decarbonize more quickly. When you look at the environmental footprint of a mine, one of the biggest parts is the consumption of electricity. So I was working on thinking through how do we decarbonize electricity more quickly, and came across the point that there are many more disused and legacy mines in Australia than there are operating mines, which I felt was an astonishing finding. And it turns out that research from important institutions, including the Monash University, have identified nearly 100,000 legacy mines in Australia. Well, more than we have operating. It's incredible. There are millions around the world. And this got me thinking, well, how might we be able to better use the legacy infrastructure that's been invested over a great period of time to help the current infrastructure decarbonize more quickly?
Yeah.
And that was really the start of Green Gravity, where we started thinking very carefully about what is it that legacy mines may have that could contribute to the energy transition. And in that case, we felt a real opportunity existed in the area of energy storage to help the renewable energy transition.
Yeah, definitely. And that fits into that circular economy argument, right? So you're reusing infrastructure that already exists.
It's a huge passion. We really want to understand how to reduce the waste, reduce the resource consumption in this world, at the same time as decarbonising the bits that we do need to use. And undoubtedly, we have to continue extracting resources and making a vibrant mining and extractive industry sector. That's critical to how we live. But by doing it in a way that's more circular, that has less waste and can reuse things we've already done, I think is a really important ambition.
Yeah, and this is a little bit of a tangent, but what would happen to those mines, those legacy assets, those legacy shafts, if you weren't using them?
Yeah, well, it turns out many of them are very old and they're left for the public, the governments to work on managing and mitigating the impacts, and they can be to biodiversity, to groundwater, to safety and other things. In more modern times, mining companies put in place plans to ultimately rehabilitate sites, and that can include returning mines back to the natural landform, back to natural forest, to pastoral land and other things. So there's a mixture, but fundamentally there are many sites for which there's still a lot of work to do. Yeah. Because the overwhelming majority of the legacy sites in Australia and we think globally are not actually rehabilitated yet. Yeah.
Oh, very interesting. Okay, so energy storage. This is probably in your decarbonising exploration at BHP. You would have definitely got into this sort of data.
Look, I think it's a really interesting question. When we try and decarbonise the electricity system, what we're really saying is we want to take electricity produced from very stable production sources like coal and gas, and we want to replace that with energy produced by variable sources like wind and solar. And they produce when the wind's blowing or when the sun's shining. And so what you're doing is replacing something that's low variability with high variability. And in order to manage that, we need to think about how to match the supply and demand. And the curve that we see in front of us represents this point. You can see here a few lines. Firstly, the yellow. The yellow is the solar production, and it generates when the sun's out. You can see the wind generation in green, and then you can see the demand profile for electricity. And this is an example day in early 2022 for the national energy market. You can see that the demand moves through the day. But what is the most stark thing about this curve is that it doesn't all match at any point in time. And as a result, the more renewable energy we put into the grid, which helps decarbonize it, the more of a demand we have to be able to make these curves match together.
Yeah.
And the way to do that is by generating energy storage capacity. And in order to make energy storage work, what we do is we take the excess generated in the middle of that curve, say in the middle of the day when we have excess solar, we take that and we put it into a storage. And then when we need it later, we take it back out of the storage, which is the areas where you see in blue in this chart. So that's how it works. What it tells you is the more renewable energy we bring into the grid, the more energy storage we're going to need.
Yeah, definitely. And this is a pretty basic slide, but for our non-technical people that are in the audience, we kind of need this, because the average person, I had A friend of my mum recently asked me about energy storage and solar, and wanted to know if she was going to put solar on her roof, could she use her air conditioner at night time, and would that reduce prices? I said, no, you can only generate and consume solar at the same time. You can't store it unless you have a storage medium. So it's not the same thing. So it's quite hard for people to understand how it actually works.
Absolutely. And we haven't really needed lots of storage assets in the past. So this is an emerging area. And it's only in countries like Australia, where we're at the cutting edge of bringing more and more renewable energy into the system, that the issue is really coming to the forefront of having to sort out how are we going to add more and more storage to the system. And traditionally, the overwhelming majority of energy storage comes from pumped hydroelectricity, which is a great technology. It's been around for 100 years, but it has limitations at how fast we can bring it to the grid.
Yeah, definitely, and geographic locations as well, where it's applicable.
Correct.
Okay. So your track record so far?
Well, we're really proud of our track records so far, Dave. We're moving fast. We built the company in 2021 and launched in 2022. Since launching, we've added more than a dozen members to the team from all sorts of backgrounds, from energy, from mining, from manufacturing, from technology, from finance. And one of the things that's been really important is that the storyline and mission of Green Gravity has attracted many people. And so we've attracted really talented, very senior people that are very capable. And so we're really proud of being able to build a quick team. We're really proud of being able to build a team with great capability. This year, we've continued to develop the engineering. We've continued to engage with many stakeholders to enable us to now go and demonstrate the technology at real scale, to start to work very definitively towards commercialization, and to being able to get the market ready to receive what we think is a groundbreaking technology that will help accelerate the penetration of renewable energy into the grid in the near term.
Yeah, look, it really doesn't surprise me that you've got, and I know a couple of people on your team, so I know the caliber of them. It really doesn't surprise me that you've been able to attract them, because one of the things I find in working in this industry is a real passion for sustainability. And lithium-ion batteries are a great technology. Don't get me wrong; they have their place in the energy transition. Other energy storage technologies, such as yours, have their place as well. But what I find really interesting about the discussion in various social media platforms is a real polarizing nature of lithium-ion versus other energy storage systems. And people do really gravitate to the energy storage systems that aren't lithium-ion because it's either environmental or social impacts or other reasons, but they do have a strong emotional connection to a more sustainable solution.
Great point. We're definitely seeing an overwhelming amount of support for finding new options, for finding ways to improve sustainability even further. And for the transition, we need all options. And lithium ion is a fantastic technology, and there will be limitations to it. And it is already suffering a huge amount of demand, which is causing supply constraints. And you've got to look no further than the electric vehicle market to see the important impact that lithium ion is having there. We think that in stationary grid applications, we just need as many options as we can get. There's a huge demand growth. There's an important role to play at bringing renewables into the grid and reducing the carbon intensity of electricity. And all storage technologies, including gravitational storage, have got a really important role to play there.
Yeah, great. And so how does your system work? I gave a quick illustration at the start, and wondering, is it much more complicated than that?
It's not materially more complicated than you put forward, Dave, in your excellent piece of physics. What I would say is you posed a challenge in your opening about the scalability. And that's exactly the challenge that we've taken on at Green Gravity, is to say, well, if it can work at a small scale, can we make it work at a big scale?
Yeah.
And the physics, as you point out, is really about mass and height. And so what we've been able to do is have a look at many of these legacy mine sites and understand what kind of height might be available. And it turns out that there are many, many mine sites for which the height is enormous.
Yeah.
And let's put it into context. the Sydney Tower, that tall spire in the centre of Sydney, is about 300 metres tall.
Yeah. Wow.
The average of the legacy mine sites we've studied so far is more than 400 metres deep.
Yeah.
So we're talking about very deep holes. We're talking about quite wide diameters and very stable holes in many cases. Yeah. So when it comes to the physics of gravitational energy storage, height is good. We've got a very impressive asset base of a great deal of height.
And so you said they're quite wide as well. So were they originally in those shafts originally dug for ventilation, or would they be for transport for workers up and down the shaft?
Yeah, all of the above. And so this is the beautiful thing about mines, is that there's often multiple mine shafts.
Yeah.
Because of what you say, you need ventilation, you need to bring people,
back up, right?
You need to bring materials out.
Yeah.
So if you think about a mine shaft, even very old ones, even back in the 1800s, the challenge was always the same, which is you have to take things down and back up, and you have to get air down and up.
Yeah.
And so even very old mine shafts are still quite decent size.
Yeah. Yeah, very good. So how do you use that height to store energy?
Well, it's a simple sort of three-step process, Dave, and I'll take you through it. The first thing we do is we take a really heavy mass and we lift the mass from the bottom of the shaft to the top of the shaft. And as per the calculation you showed earlier, we create an energy exchange. So there's a quantity of energy storage that is imparted, or there's a change in the potential energy of the mass that becomes imparted by that movement. So as we lift that mass up, we're using the surplus renewable energy from the grid to do that.
Okay.
We then store that mass on the surface. We just sit it on the ground. And then at a later time, say in the evening, when we need to redistribute that energy back to the grid, we lower that mass back down the mine shaft. And in doing so, that turns our regenerative electrical motor, which can be used to act as a motor to pull up or as a generator as we go down. We're able to regenerate that electricity back to the grid.
Okay. So you just convert potential energy into rotational kinetic energy, which then turns your electric motor, which then creates electric current.
That's exactly right. Now, we can do that for one mass, and that can generate a good amount of energy. We can do it for lots of masses, which our system enables to be able to really pack a lot of energy into a mine shaft. And we're talking about an energy capacity that's equivalent to the average of the current big batteries being installed into the grid with the lithium-ion technology. So these are a very large amount of energy that we can bring to the grid and perform an energy storage role by reusing the infrastructure that was there.
Yeah. And so the grid infrastructure, because when I think about mines, I think about remote locations, and I think remote locations, they're not connected to the grid. But these shafts are actually connected to the grid because they're originally designed to be driven by electric motors.
Exactly. So you just worked through the important piece of logic, is that, of course, every mine shaft originally had to have electricity there. And when you then go out and have a look at many of these shafts, we found some important things. So firstly, many of the shafts are still connected to the electricity grid.
Right.
Or indeed may have had some decommissioning, but are still very close to the electricity grid. And the second thing we found is that the distribution of mines is much more wide than perhaps one might expect. And these mines in our history have not all been out in the middle of the outback. There are many mines that have been right in and around urban areas all the way through the whole of Australia, actually. And think the Hunter Valley and the Illawarra, think Ballarat. These sorts of areas are dense urban areas and yet have rich mining histories.
Yeah, well, that's the thing about mines and resources, right? You mine and exploit the resources close to the population because it's the lowest logistics cost. And the only reason they're remote is because we are getting to the end of the available resources. So we end up going to the remote locations. And originally, I'm sure in Britain, when they first started using coal, they just dug it out of the closest little mine and then ended up having to go further and further.
Oh, it's completely right. I mean, early in the development of green gravity, the team took a trip to Ballarat. It's an amazing town. I highly recommend it. Yeah. And Ballarat was, of course, the centre of the gold rush. There are mine shafts all the way through town.
Yeah.
And that was quite striking to me because I hadn't kind of thought much about where mine shafts were really in that context. And what it turns out is there's many shafts, and some of them are old, some of them are new. They're in varying conditions, but what we know is they all have great vertical height. And so with the right technologies and the right application and effort and collaboration, many of these assets could give back in the future to our energy transition.
Okay, so many of these assets. So how many are there really?
Well, let's have a look at a map. And this isn't a map I produced. This is a map produced by the Australian federal government. And you can see here the distribution of mining assets. They are remarkably consistent around the entire country. Look, many of these are legacy mines. Some of them are operating mines. Some of them are all manner of mining infrastructure. But this doesn't include deposits and some of the other quarry infrastructure and those sorts of things, which are, again, a more prolific set of dots again on a chart. So I think what you can see here is, Dave, that wherever the electricity grid is, there's mines not far away. And in fact, some of the time when we're looking at mines, what we've found is if you trace the main transmission infrastructure, if you follow it on a map, at the end of the transmission line, you find a mine. Because it just so happens that in many cases, the grid was built to support mining in many areas, including particularly in Western Australia. And you can see all those green dots there in the sort of centre of Western Australia. And that's a great example. But it's also the case all the way down the East Coast.
Yeah. Well, you know, as we talked about earlier, is that mines consume a lot of energy. And so it makes sense to connect the electricity grid to a mine, make that work.
It's a really important point. And so the technology that Green Gravity is commercialising has the opportunity to help existing mining operations decarbonise their asset more quickly, because often there are legacy mining shafts or legacy mining assets either co-located with an existing mine or very close. And as a result, we have the opportunity to bring a really sustainable lens to how to bring more renewable energy more quickly into the mining sector. But also, because of the grid connection and this large distribution of locations, we also have the opportunity to use those assets to bring renewable energy right into the core of the energy grid as well, which is a great opportunity.
Definitely, like the mining industry, the impacts that it does have, that they have been on the front foot in terms of renewables for a decade. You know, I've seen some really impressive stuff, but there's a limitation to that in terms of how much they can store. Typically, they'll do a solar wind installation with a diesel as a backup for their 24/7 operations, but that's only a small percentage of their energy consumption. Most of it's still in diesel and heavy moving equipment and things like that. So if we can get more reliable electricity with renewables and storage, they can electrify more of their operations, reduce their dependence on diesel. That's just got to be a good thing for the planet.
And I think it's completely right. And I think we can do this in a way that's economic and in a way that's more sustainable than ever. We can reuse infrastructure and bring a great sustainability footprint. And that's going to just mean that the energy transition can accelerate, so we can actually decarbonise our industries more quickly.
And electric operations, and this is another tangent as well, but I did a study for a gold mine early in my career about electrifying their heavy moving vehicles, so their haul trucks out of a pit with a electric trolley assist, like a tram line sort of overhead at the power lines. Everything made sense from a financial perspective, from a reliability perspective, from an availability perspective. The only problem is that they didn't have access to grid electricity. So if you can get them that reliable supply of electricity, their operation can be much more efficient.
Well, this is the beauty of our technology. Wherever there is an appropriate legacy mining asset, we can couple that directly with renewable energy and help even a remote mine site decarbonise its energy consumption quite quickly. So I think we're very flexible technology in that sense.
Great. Well, that's very exciting. The scale's big, and that's just a map of Australia.
Correct. Multiply it by 10. Multiply it by 10 if you want to think about North America. We're working with stakeholders in India, South Africa, South America, in addition to North America. And what I can tell you is the same fundamentals apply. Everybody in those jurisdictions is looking to reduce the carbon footprint of their electricity grid, and those jurisdictions have got legacy mining from hundreds of years of mining, and
Yeah.
so the same basic recipe, I think, applies globally.
Yeah, we have a great mining industry in Australia with some very high quality resources, but there are mines everywhere in the world. You know, everyone needs resources,
Right.
and so there's opportunity there. Very interesting, very interesting. All right, so we've talked about using legacy shafts. You lower weights, lift them up. There's lots of opportunities in Australia, which is probably lots of opportunities in the world. Where does your system really work best? Like where do you find that your system is really going to beat all the competition?
Well, I'd like to start with the point that we have a very strong sustainability credential on this technology, and this sits firstly with the environment. The reality is, by reusing infrastructure that is already in place, we don't have to disturb new land. So our credentials on land use, on converting things like farmland, biodiversity impact, we have an excellent credentials in this area because we don't need to create impact. Further, we don't have to create an impact to the water system. And so many technologies are quite water intensive. We don't need a water intensive platform. So I think we've got a really strong case to say our impact on the environment is very, very modest.
Okay.
Secondly, because we're able to use reasonably simple technologies, we're able to reuse infrastructure that's already in place, we're able to generate a very long asset life. So our system can last for decades. And when we're talking about the electricity grid, this is a good thing. And so that plays into our cost structure. By being able to reuse infrastructure, we get lower cost. By being able to have very long life, we get a very good low total cost of ownership. So our system is very economic because of those factors. We're also able to present a very good story around safety. There are technologies that have problems with thermal runaway, with gas production, or with supply chain safety. And I think it's safe to say that the green gravity technology is able to be very, very strong in the area of delivering safety for people involved in the supply chain or operations of the technology. We're also quite efficient, and importantly, the supply chain that sits in front of our technology is reasonably short and reasonably local. We want to reuse things that are there locally in jurisdictions. We need to bring some motors and electrical equipment out of the global supply chain, but we don't have a long processing chain. We don't have to bring chemicals. We don't have to process this and process that. So I do think we've got an incredibly robust supply chain that brings sort of flexibility to deploy locally at small or large scales, but that we can have a pretty low impact effectively from this tech. So I think this is where we really excel, is this area.
Yeah, well, it's a huge benefit not having to dig that hole. That's definitely going to reduce your capital costs. And
we're happy for others to dig the hole, and we'll use it for our tech.
Yeah. And this is the supply chain one that's really interesting in this industry, particularly around, as you said, you're not reliant on extensive minerals processing supply chains, which lithium ion is, and other energy storage systems, vanadium, redox flow batteries, etc. So it's relatively simple. Obviously, you're going to need a lot of copper and some magnets, but that's pretty achievable in terms of what we can get and do in Australia. But what's interesting with the supply chain one is you're not dependent on any critical minerals. So I think, I'm not sure if copper, I'd say copper is a critical mineral, but it's the supply chains are more established and we have more sources of copper. But some of the other critical minerals like cobalt, manganese, nickel, which are harder to get, you don't have that exposure to that commodity risk.
That's right. And so those supply chains are under stress. There's no doubt, because there's just huge demand and a huge need to get on with decarbonisation globally. I think we do our bit by releasing that incremental bit of pressure off those supply chains by not requiring those inputs. So I think we can have a really important, if somewhat kind of niche, but an important contribution to just that little bit less pressure on those supply chains.
Yeah, definitely. And that's really what BatNav's really trying to achieve is to help every energy storage technology find its right application, and so that we can make sure that we have enough energy storage to accelerate the energy transition.
Well, we're in a world now, Dave, where energy security is a topic that gets more and more conversation, and rightly so. And I think what that requires is industry and technologies to continue to come forward that help provide really robust energy security at a national level.
Yep.
And I think our technology is part of that puzzle, because we can reuse assets inside a nation. We can effectively be a local contributor to the energy transition in any location around the world.
Yeah, great. Okay. What does the future look like for green gravity?
Look, our future hopefully is really bright and exciting. We're excited. And what I think the near term looks like for us is a real move into the physical asset side. So we've done a lot of work on our engineering technologies, on building capability in our team, and in engaging stakeholders to understand the market and make sure that our technology will serve the market in the way that's required. Our next stage is physical assets, building demonstration plants, and working with important stakeholders in energy and mining and with regulators to enable a swift and hopefully very accelerated commercialization path in the coming years, so that we can really have an impact to the energy transition at scale and to help that renewable energy penetrate the grid more quickly. So that's, I think, our future, working very hard with important stakeholders and proving the technology up in real hard locations.
Yeah, great. And I was really impressed with you. Yeah, you recently got back from a trip to the US. You're in New York and Washington, meeting with investors and other energy storage companies and government officials there. So you've really got that, you've got the right connections, and particularly in the resources industry. You work for BHP at that global executive level. You know the lay of the land in terms of the resources sector and the opportunities that are available there, and you seem to be taking some really positive steps to really make it happen.
Yeah, that's completely right, Dave. And the reception in the United States was exceptional. People are really tuned into the question of energy transition and to the need for energy storage, and new bright ideas like gravitational storage, and then specifically like green gravity's technology definitely fits into the thinking around what needs to be done. So we've received a very warm reception, and the same for other countries. And we're going to be having very important conversations over the coming months with multiple jurisdictions, including Australia, of course. But we do see a need to move quickly. There is a huge demand out there for energy storage. It's important that we satisfy it, and we will have our place in that. So I think you should expect to see more headlines around green gravity, around accelerated commercialization, and around multiple jurisdictions that we feel are very attractive for our technology.
Mark, thanks very much for joining us for our first Seller webinar. I'm really thrilled that you participated with us, because you're such a bright and optimistic guy, and you've taken on something which is a huge challenge, and you're really giving it everything. So I really appreciate you spending the time today.
Thanks, Dave, and congratulations on your podcast series. You're making a real difference. It's on all of us out there to better understand what we can all do in the energy transition. We can all do our part, and being part of it, of educating ourselves and finding what we can do is just so important.
Great. Thanks very much, Mark.
Thanks for having me.
So now that we've come to the end of our first webinar, I'll give you a little bit more information about BatNav. We exist to help the numerous emerging and evolving energy storage technologies find their right customers. And we provide expertise that is typically hard and expensive to get. We will be the world leader to help businesses solve their energy storage problems. We will connect buyers and sellers and provide trusted world-class expertise. And we'll be known as the company that made energy storage accessible and helped accelerate the energy transition. We don't sell batteries. We're a technology company. We serve the energy storage industry, and we automate engineering and procurement services. We help buyers find the right battery, and we help sellers find the right buyers. And we are faster, cheaper, and better than the alternatives. Thanks for watching our first webinar, and we'll see you for the next one.